Today's video, what is math and why is it so pretentious? Problems, solving them, adding big numbers, moving letters from one side of an equal sign to another, measuring angles, etc. This is what we're exposed to at an early age, and this is what our teachers tell us is math. And they're not wrong, but their notion, which they instilled onto you, is quite limited. So the definition of math that I like to use may surprise you. Math is the discovery of incontrovertible truths about the universe. Incontrovertible means not able to be denied or disputed. And discovered means, well, you know what the word means, but focusing on the use of the word discovery would imply that math is not invented, it is discovered. All that to say that mathematical truths are the truest truths. There's something just a bit more fundamental about math than other fields of study. And that is what makes math appealing, and that is what makes math important. But it is also what makes math pretentious. And you may be interested to find out that it was always this way, even in ancient times. In modern vernacular, we can make a distinction between theoretical mathematics and applied mathematics. Applied mathematics is problem solving, it's the math that you learned in your early years, and everyone is largely familiar with to some extent. Theoretical math is more concepts and theories and proofs. Theoretical math can also be referred to as pure math. So if we go back to ancient Greece, applied mathematicians were referred to as pebble mathematicians, or like counter, bean counter, pebble counter, that kind of stuff. And even going all the way back to ancient Greece, we see this clear divide. There's a social elite group of people who are reading and writing about theoretical mathematics, while there was a working class mathematician you would call to actually solve a practical problem for you. Think like a plumber who, instead of knowing how drains works, helps you do your accounting or helps you accurately measure how much land you have. And these working class mathematicians are found in other ancient societies. In the Middle East, they were known as al-Algabar, loosely translated to the algebra people. And they too were differentiated from their theoretical mathematical counterparts. And this video isn't some anti-high class, hoity-toity piece on these theoretical mathematicians in their ivory tower or whatever. They were, to their merit, absolutely brilliant, producing great works of immeasurable value. The geometry textbooks we use today are still highly based off of the ancient Greek theoretical mathematicians. But they were of a higher social class and more literate than their applied mathematics counterparts. That cannot be denied. The theoretical practitioners, by means of being higher class, had their works preserved for thousands of years, while on the other hand, it's hard to find records of the working class traditions because of their lower literacy rates, though some of the stuff we do know is very cool. All of this to say that there is a ton of cool and interesting mathematical knowledge that we are not exposed to in our lives. And this knowledge, the realm of theoretical mathematics, has historically been in many ways exclusionary based off of class. In modern times, educational institutions are drawn to focusing on applied math. The logic being, well, that practical math solves everyday problems, and that seems more reasonable because we want people who solve everyday problems. So, um, we kind of, in a way, that this long-standing tradition of not exposing to theoretical mathematics continues on to this day. And I don't like that. I don't think that's super cool. Applied mathematics is lovely, but theoretical math is absolutely wild. And while there are obviously crossovers and similarities, I would say that there is this whole big entire thing out there called math, and it's nothing like the thing you know and you call math. And you might really like it. Okay, so that's all for today's video. The historical information referenced in this video is from the Oxford Handbook of the History of Mathematics, specifically Chapter 2.1, the article by Markus Apser titled The Two Cultures of Mathematics in Ancient Greece. All right, see you later.